Hello, this is Big Daddy K or Ken Hill, whatever you want to call me, but here we are here to look at the series DC generator. So you'll notice I have no shunt field at all. All I am using is that other field winding called the series field. It's got 3 bumps. You'll notice in my series field I'm going to have A2 generate positive in relation to A1 being negative, which means I see positive there and negative to there. If I put a voltmeter there, I also put a voltmeter across S1 and S2. That's right here. This is our series volts. So I'll draw that in our diagram maybe to hopefully show you that S1 is connected positive in relation to S2 being negative. So I do have a voltmeter in there in my circuit. I do have an ammeter there to show me my load current. If you're wondering what that is, that's an ammeter, right? Positive to negative when you view that load. But this is basically what I've done. I've come over here. Here's my A2. A2 goes out to my ammeter and goes to my load. This voltmeter is connected across the load. Then our black wire comes back and goes to S1. Then S2 is going to jump to A1. This is just a voltmeter connected across S1 and S2 to show you that S1 is positive. So that is pretty much what we're looking at here. So I'm going to start this up. Hit my AC, inject it with DC, synchronize it. Head to about 80 volts there. Now you'll notice here is my series field. I have about 5 volts there right now. Just like those other graphs I show you in class, it's basically showing you this right now. Well, that's pretty bad, eh? This is my no load voltage and my full load voltage. Right now I'm about here at 5 volts. This curve should keep going up as I add load, then I become saturated. We might not be able to get to that point with our lab today, but I will basically show you this effect. There I have 5 volts. I have no current flowing through because I have no loads on. So I'll just get this on here. There's no voltage across my series field because there's no current flow through my load yet. So this is what happens. This is my residual magnetism in my graph. When I turn on load, I had a little bit of load current. I developed about a 262 millivolt volt signal across my series field. You'll see the light is just a little bit on. So as I add more load, I increase the current flow through my armature and it builds up some voltage. It's also a little voltage built up my series coil. Turn on more light, more load, more current flow through the armature and through the series field, and my voltage builds up. More and more, that's about full brightness. So right now my full load voltage is about 72 volts. My no load voltage was about 5 volts, so you can do a voltage regulation percent for that and you'll find out it's very high. Maybe about 60% we could say, something high like that. The other two, the separate would have had about 10% voltage and the self would have had about 14% voltage regulation. So the higher the voltage regulation, the worse it is. So this is about 72.1. The only thing really controlling my output voltage is my load in this circuit. I don't have no rheostat. It's not going to do nothing to this circuit. It's just going to basically build up voltage till it's saturated. So right now, at full load, this is the voltage across my series coil. 3.5, very low voltage drop because it's basically a very low resistance circuit, no? So that is about positive 3.5 volts. And I will prove this to you by changing polarity on my voltmeter. Put the common to S1 and now put my positive to that. Is that not telling me negative? So that's basically backwards now. So I'll go back and put my positive lead of my voltmeter back on S1. and you'll see it's positive voltage now because S1 is generating positive, all the currents flowing out of the armature through the load, through the series coil and back to the armature circuit. As I lose load, I'll go, oh, that's a hot one. As I lose load, I basically also lose output voltage, no? And I'm back down to my residual magnetism. That's about all there is for the series generator. It's not good for much, maybe some line loss scenario, but most of our distribution is not in DC, at least in Saskatchewan, so therefore it wouldn't be something we'd use that much. So if I show you this ammeter here again, right? All the current, 6 amps I guess. 6 amps is what's flowing through my armature circuit. Simply just a series circuit, as it says, series generator. So I hope that helps you. Lose load, you'll see the lights dim also. So that should prove to you that as load increases, current increases, and your output voltage will build up. Not very practical for much in the real world. Can't really reverse the current flow through there. Not too sure what it would do, but I bet you it would break down some stuff. So maybe just for you guys, I'll check it out here. See, look, and now it's working against that magnetic field, no? So it's kind of got the a differential characteristic. It's limiting current, no? So that's not a good thing to do. But it can be done because this coil can be polarity, change polarity, no? So now that I got it back right, go back over here. I add load, I build up voltage. So that's pretty much all there is to a series generator. Thanks for your time and have a good day.